Hey guys, I hope you're doing really well. This is my switch, and as you can see it's in a bit of distress. So when I power it on, the LEDs come flashing on and they go off again. Now this happened after a power cut, so I think there's something wrong with it. I've just replaced the one on site with a new one, and we're going to take the back off this and see if I can get it working again.
Sorry about that, had to be a little bit quiet in the office so as not to disturb anybody. Okay, I've taken off the lid off this switch, and for anybody who's seen the previous video that I did on the other switch, this looks similar. So we've got a small little power supply in here, and that feeds power out to like a main board here. And on this one there is actually a third board, because we've got a white connector here, and that brings a signal out to the front bank of LEDs out here. Now we were able to see that those front bank of LEDs earlier on because they were flicking on and off. But what's nice about these is we have essentially 3 different parts of the circuit that can be disconnected and tested independently. So what I'm going to do first is I am going to disconnect this, and I'm going to then check to make sure that we've got 5 volts coming out of here. I've disconnected the power board from everything else, and I want to just check with it plugged in if I'm getting voltage, if I'm getting the correct DC voltage out of the pins down here. Now we introduce our multimeter in volts DC in a 20 volt range, and you may remember on the previous video that the wires were black, red, red. So I'm going to assume that that's ground, and positive. So what I do is I take my black probe and place it to ground, and then I take my red probe and I measure here, and I measure here, and then I just measure here as well, just to confirm that it's ground. And when I did that, I find that we have the following on each of the pins. So the black, red is ground, 5.2 volts and 5.2 volts. Now that's a stable 5.2 volts, so it looks like this power adapter is working. Now, one thing that a lot of you might have spotted here is that we have one dodgy looking component on the board. It's more visible from other angles, but if you look at it, you can see that that capacitor is starting to vent. Like I said, it's more visible from the side, but you can even see it from here. It's starting to bulge at the top as opposed to this one here, which is flat. However, I am conscious that this happened because of a power storm. So this fatigue injury here is not likely to be the cause of that. And you know what, you will see it a lot of the time. You'll get in certain electronic devices, they'll have really badly bulged capacitors, but still you'll find that won't be the fault. Now I'm going to replace that at the end, but just in case anybody has spotted that and thinks that that's the issue. Now it could be the case we're getting 5.2 volts here, but when it's under load that it fails. But in my experience, if you're seeing 5.2 volts there, then we should be good. So what I'm going to do next is I'm going to connect in the next board and see if that stays at 5.2 volts. We've established that we've got a good 5.2 volt DC coming out of our power board, so I now connect in my main board, but I haven't yet connected back in the LED board. But what I'm going to do now is take measurements. So I'm placing my black probe to a ground, so we can just find ground right here, and I take my red probe and measure the 4 pins coming in from the power board. So I'm measuring here. You have to dig into these because you have to dig into the contact right there. So I measured here, I measured here, I measured here, and when I did that, I found that the following voltages were present on those pins. So we've got 5.2 volts, 5.2 volts, ground, and ground. So that looks good. It looks like there's nothing on the main board that's pulling that voltage down or causing it to cycle or anything like that. I haven't tested it to see if it's actually working or if it'll work without the LED board, but just for the moment I wanted to confirm that those voltages are online there and they look good. Now one thing I wanted to do here was, before plugging in my LED board, I just wanted to check what the voltages were on the pins going to that board. So this is the little connector right here that goes to our LED front panel, and once again in volts DC with my black probe on ground, I take measurements here. So I measure this pin, then this pin, then this pin, this pin, and this pin. And when I measured those, I found that we had the following. So we had a 3.3 volts, a ground, then there was a sort of a nondescript, that might be for signaling, and then a 3.3 volts and a 3.3 volts. Now, because it's exactly 3.3 volts, it looks like it's it's on approximately the right amount, so that looks good as well. So the next step I want to try and do is to plug in my front LED board and see what then happens.
I've plugged back in my LED board, and as you can see, when I measure the voltage at this same point, once again, where we were getting 5.2 volts, it's now power cycling. And you can see from the back that our LEDs are flashing, that board is still flashing on the front. So just to reiterate, that was 5.2 volts. Then I plugged in the front LED board, and it's now power cycling. So it seems like there's an issue with that front board. What I'm going to try and do now is I'm going to just try and disconnect that and see if it stabilizes. Okay. Yeah, so the voltage is starting to stabilize with that board disconnected. So it looks like we've got a problem with our little LED panel at the front. So I'm going to take that out and we'll have a look at that next.
This is the front LED board that I've pulled out. So as you can see, there's 48 LEDs on it, and then one LED for the power light. This is a 24 port switch, so you've 2 lights for each of the 24 ports. So what I wanted to do first was to check and see that all of these LEDs are working. There is a chip on the other side of the board, this one right here, which controls those LEDs, but I decided I would have a look at the LEDs themselves first, just see if I could get them to power on and just make sure that none of them are shorted, and possibly maybe that's what's causing the power to cycle. So I introduced my power supply and I put up 3.3 volts with a current limit of 30 milliamps. This is particularly important with LEDs because if we're testing them one by one here, there's no resistor, and these LEDs always have to have some means of limiting the current, or else they will just draw whatever current you set it at. If I set it at 3 amps and 3.3 volts, it'll take the whole 3.3 volts at 3 amps and blow the LED off the board. So what I'm doing here is I'm setting a 3.3 volts 30 milliamp limit. I'm connecting my black probe to one side of an LED and connecting my red probe to the other side. I don't normally like crossing these probes, but I have no option on this one. So one by one I go along these, and when you go along them, what you'll see is, I've got a quick video of what I did here. It looks something like this. So you placed the black probe on one side and the red probe on the other side and inject the voltage into it. And as you can see there, I went along each one. And as I went along them, you can see that they're all lighting up. Now there was a few where they didn't light up as much as I thought they would. What you're looking for is that each one should light up roughly about the same. But there were a couple that didn't light up as much as the others. I did temporarily desolder those, and it made no difference. So each of them pretty much checked out. So there was no shorted LED that was causing this fault. Okay, at this point I decided to swap out this capacitor. You might remember I pointed this out earlier on, but I didn't think it had anything to do with the fault. We're getting a stable 5.2 volts out of the power supply, and even when I plug in the main board, it's also still 5.2 volts. But just to discount it, I'm gonna remove this and replace it with a good capacitor, and then we'll keep troubleshooting from there. As you can see, I've just replaced that vented cap with one that has a flat top.
This is 16 volt, 1000 microfarad. Now, the most interesting thing about this is, when I jump out to the front, would you believe it? It's no longer power cycling anymore. I've got a stable power light over here. And now, when I plug my laptop into port 23, the light comes on. And I've checked, and the switch is working, would you believe it? So that capacitor is what is causing the power cycling on the front. So just to explain this, I think what's happening with this was that the power supply initially was reading 5.2 volts. And even when I plugged in the main board, it was also reading 5.2 volts. But when I put a bigger load on it and I needed to draw the current for all the LEDs, it wasn't able to handle that with that bad capacitor. So it's very interesting to see, you know, because sometimes you could do what I do and say, okay, look, there's 5.2 volts coming out of that power supply, so it's obviously fine. But it can be the situation that it's only when you put a load onto the power supply that it actually fails. And this is one of those scenarios. It's also a good lesson not to just, you know, look past something that you know is bad and troubleshoot past it. If the capacitor is bad, just replace it and then keep troubleshooting from there. So that's my video for this week. I know a lot of you don't like switches. I like fixing switches. We get quite a few of them in, so I've got a lot of content that I can make out of them, if you want to put it like that. But I'm going to do a laptop next weekend. But just think about it. That one component right there, well, the old one that was vented, that took out the phones, TV, internet, medication for a nursing home for about 6 hours until we were able to get out and replace it. Just one little component that's worth about 20 cents. Isn't that interesting? Well, maybe not. But that's a video for this week. I'll be back with a laptop next week. Thanks, guys.